दिस इज थ्योरी अबाउट द थेवेनिन्स एंड नॉर्टन थ्योरम। नेक्स्ट हम लोग अभी देखेंगे इसमें लिमिटेशन क्या होती है, एंड देन वी विल सी द न्यूमेरिकल ऑन द नॉर्टन थ्योरम। और नॉर्टन थ्योरम के न्यूमेरिकल जो है मैं पैरेलली कराऊंगा थेवेनिन्स थ्योरम के साथ, जिससे कि जो मैंने पढ़ाया है वो आपको एकदम क्लियर रहे। तो अब देखते हैं हम इसकी थोड़ी सी थ्योरी जो रह गई है, दैट इज लिमिटेशन, और हम देखेंगे इसके बाद न्यूमेरिकल। तो देखते हैं, स्टार्ट करते हैं अपनी लिमिटेशन ऑफ द थेवेनिन्स एंड नॉर्टन थ्योरम। तो लिमिटेशन के लिए याद रखना जितनी भी थ्योरम्स हैं एक्सेप्ट वन थ्योरम, जो एक थ्योरम है जो लीनियर और नॉन लीनियर सर्किट दोनों के लिए एप्लीकेबल है, दैट इज द टेलीगेंस थ्योरम। बाकी जितनी भी थ्योरम्स हैं वो सारी जो थ्योरम है वो लीनियर सर्किट के लिए वैलिड है। अब तो थोड़ा सा लीनियर पे हम लोग फोकस करते हैं कि लीनियर और नॉन लीनियर और क्या क्या हो सकता है ना। लीनियर लोग जो लीनियर एलिमेंट्स है वो कौन से होते हैं, आर, एल और सी एग्जैक्टली। बट व्हेन द आर, एल एंड सी आर लीनियर, एट व्हाट कंडीशन, at what condition are L and C are linear? क्लियर है? तो L और C लीनियर कब होते हैं वो देख लेते हैं एक बार, क्लियर है? So that's why अगर हम लिमिटेशन एक और बनाना चाहें, the Thevenin's and Norton theorem are valid when the initial condition of the inductor and the capacitor are zero. That's maybe addition of the limitation in all theorems, clear, except the Teligent theorem. So देखते हैं क्या, एक एग्जांपल लेते हैं यहीं पर। Now we know that the voltage across the inductor is L di by dt. L di by dt. Agree? So if you see the dit upon dt equals to VL upon L, from that I can write dit upon dt equals to VL upon L dt. Now integrating on both sides, and I have IT equals to 1 by L VL dt. Agree? Now taking the limits, limits is from 1 by L minus infinite to T VL T dt. Agree? Now further, if we break the limit from minus infinite to 0 and 0 to t, meaning क्या है इसका, minus infinite to 0 and 0 to t. So I'm breaking the limit. So breaking the limit from this to this. So 1 by L is minus infinite to 0. This is VL of t dt plus 1 by L 0 to t that is equals to VL t dt. So the current through the inductor is IL of t equals to, now this thing in case of inductor is called the initial current stored in the inductor. So I can write this as IL0 minus, clear hai? Next I can write this as plus 1 by L 0 to t VL of t dt. Clear? Now if you plot the curve of this thing, if you plot the VI characteristic curve of this thing, then we have, this is the initial current stored. Agree? On the y-axis I take the current, on the x-axis we will take this integration of VL dt. Now we have some amount of current, that is IL0, clear, IL0 minus, and after that your curve will look like this. Agree? So if you see, this curve is non-linear, clear है? Now if I put this initial current to 0, then your curve becomes like that, and this is the linear curve. So what is the meaning of that? These theorem are valid for the linear elements. Meaning इसका अगर हम सही से देखें तो meaning क्या हुआ, these theorems are valid, when initial condition in inductor and capacitor are 0. क्लियर बात? और इंडक्टर और और कैप्चर में इनिशियल कंडीशन है क्या होती है, ध्यान से सुनिएगा अभी। इंडक्टर स्टोर्स करंट, सिमिलरली कैपेसिटर स्टोर्स वोल्टेज, now inductor stores current, capacitor stores current, or we can say inductor stores energy, inductors and half Li square. Inductor stores energy in the form of magnetic field, and the capacitor stores energy in the form of electrostatic form. So these things should be zero while you are solving your Thevenin's and Norton theorem. In general, you have to keep in mind all these things should be valid for all the theorems except the Teligans theorem. Clear? So अगर मैं इसका meaning देखूं, these theorems are valid for the linear elements, or we can say these theorems are valid when the initial condition in the inductor and capacitor are zero. Now next limitation is what? These theorems are valid for the bilateral element. What are the bilateral elements? Now bilateral elements are R, also R, L, C. Clear hai? Now next limitation is what? These theorems are not valid for the ideal voltage source, ideal sources. So you have seen this thing, because when you transform these two, it is not possible. Now note number 1, it can be applied to AC and DC theorem, DC circuit. So it is applicable for the DC as well as AC. Now this the condition that we have studied, that the initial condition in the inductor and capacitor are zero, it is mainly with respect to AC circuit, because in DC there is no inductor and capacitor. Now next part is what? It is applicable for the active and passive. Yeah, the energy sources are the active, and the R, L, C are the passive element. Next we will see it is also valid with or it can be applied with the independent and dependent source. Yeah, it is also true. Now last one also we can say that can be applied in S domain, okay. S domain का मतलब है अगर हम लाप्लास ट्रांसफॉर्म का यूज करेंगे, then you can have also the Thevenin's and Norton theorem in your further study, or in higher level competitive exam. You will have such type of problem that is given in S domain or Laplace transform domain. So this is about the limitation of the Thevenin's versus Norton theorem. Both are the same. And let's take one numerical on the Norton theorem. And keep in mind, हम लोग जो इस न्यूमेरिकल को देखेंगे वो दोनों मेथड से देखेंगे, कि थेवेनिन से भी देखेंगे और नॉर्टन से भी देखेंगे, और फिर देखेंगे हम लोगों को क्या करना चाहिए कि न्यूमेरिकल जो है नॉर्टन से जल्दी सॉल्व हो जाएगा या थेवेनिन से, और एक ही थ्योरम पढ़ने से जो है हमारी दोनों थ्योरम क्या हो जाएंगी, कवर हो जाएंगी. सो जो मेरे अकॉर्डिंग जो फोकस है वो आपको थेवेनिन थ्योरम पे करना है. मैंने ऑलरेडी कहा था जब मैंने स्टार्ट किया था कि थेवेनिन थ्योरम जो है वो रिलेट करेगी नॉर्टन को भी, और थेवेनिन थ्योरम भी जो रिलेट करेगी वो किसको करेगी, मैक्सिमम पावर को. सो सॉल्व करते हैं हम अपना न्यूमेरिकल, तो ये इसको इरेज कर देते हैं. Now, so we will start our numerical that is based on the Norton theorem. So first I will solve this numerical by Thevenin's and then Norton, and we will see the difference. What is the difference between these two? And if you see the numerical from the both method, you will have a clear picture of the procedure, and your doubt will be 101% clear that I have written in the theory what is the difference between the Thevenin's and Norton. Okay, so start करते हैं हम लोग. So I will take the numerical from the left hand side for the Thevenin's. With Thevenin's से start करते हैं इसको, and on the right hand side we will take Norton. Okay, so and simultaneously we will solve this numerical. Okay, so load is already removed. So the first step is both are in same. Okay, so first step is finding VTH. Finding VTH. Now for the VTH, I just draw the diagram. Just take the diagram. It is 2 volt. That is 3 ohm. It is 2. Also it is 2, and it is 4 by 5. And this is your A, and this is your B. So now first step is finding VTH because load is already removed. So load को हम लोग अगर हमें थेवेनिन वोल्टेज चाहिए, so this is your VAB or VTH or VOC. So according to me, I will find this VTH by again different method. This voltage by the Ohm's law, by the if you apply with the nodal or with the voltage divider. But this time I will use voltage division rule. First, कैसे लेते हैं voltage division rule वो देखते हैं. Now this is a 2 volt current. Now up to this point, the current will coming, but if you see this branch is open, then there is no current, and whole of the current will divide into this. Whole of the current will travel into this path. So there is no voltage. There is no voltage across the 4 by 5 ohm resistance. Just in your mind, it is nowhere present. Clear? So if you have this picture, then your VTH is across. If you see this, this your VTH is across what? 2 ohm. So for the 2 ohm, we will apply the voltage division rule. So VTH is 2 multiplied by 2 and divide by 5. It is 4 by 5. Agree? So your VTH is 4 by 5. But don't put answer that is 4 by 5. Okay. So second step what? The second step is what? Finding RTH. Finding RTH. So just see the finding RTH. Now RTH is what? So just RTH निकालते समय हमने क्या पढ़ा था? RTH निकालते समय जो जितने भी sources हैं, they are set to 0, and set to 0 means voltage source short and current source becomes open. So it is sorted. It is 3. It is 2. Agreed? So it is 4 by 5. Hopefully ये समझ में आ रहा होगा आप लोगों को. So this is your RTH or RB. Now from this side, if you calculate, these are in parallel. So 2 and 3 are in parallel. 2, 3 is 5. So it is 6 by 5. Now if you solve this value, this 2 by 3, 2 and 3 gives you 6 by 5. Then the answer is 6 by 5. So I just erase this and erase this. You will get 6 by 5 hopefully. And 6 by 5 and 4 by 5 are in series. So your RTH is what? 6 by 5 plus 4 by 5. So LCM is same. So it is 10 by 5, and 10 by 5 means it is 2 ohm. Okay, so I'm writing your answer, that is RTH is 2 ohm, and rest of thing I will erase. Okay, so your RTH is 2 ohm. Now what is the third step? What is the third step? Now third step is what? Third step was to draw the Thevenin equivalent circuit. So your VTH is how much? 4 by 5. And what is your RTH? RTH is 2 ohm, and the rest of the circuit of the left of the AB is you have drawn. So this is about the Thevenin's theorem. Now I will have direct answer without solving the Norton theorem. Now note point is what? If you apply the source transformation, if you apply the source transformation, then VTH is 4 by 5 and RTH is 2. So if you see the formula that we have written, IN equals to VTH upon RTH. So that is VTH is 4 by 5 and RTH is how much? 2. So it is 4 upon 5 into 2. So 2 से 2 cancel out. So it is 2 by 5 ampere. Now the source is providing current upside. So you will draw the circuit of upside, and RTH is equals to RN, that is 2. So without solving the Norton theorem, you have answer that is 2 by 5 and 2 ohm. So your answer should be 2 by 5 and 2 ohm. The answer will be definitely D. But I have to solve this numerical with the help of Norton theorem, and we will verify your answer that when you solve the numerical from the Thevenin's, you will have answer of Norton. If you solve the numerical from the Norton, you will have the same answer as Thevenin's. So let's start. So the first step is what? Finding the Norton current, Norton or the short circuit current. ठीक है यहाँ तक? So just ध्यान रखिएगा और अंतर क्रिएट रखिएगा कि जब हम थेवेनिन्स पढ़ रहे थे तो हमने लोड को ओपन करा था, और जब हम नॉर्टन पढ़ रहे हैं तो लोड को क्या करना पड़ेगा? शॉर्ट. So just draw the diagram. Just it is 2 volt, it is 3, it is 2, and this is 4/5, and this your load terminal. This is A, this is B, and this is your ISC, that is equals to IN, and this is also IAB. Okay, so now this ISC can be solved in a different manner. I will solve you the one method. Now this time I can use all the method that you want to know, but in the next question I will solve one method, because this is the first question for the Norton theorem. So in how many methods we can find the Norton theorem in this question, I will tell you. Okay, so for the ISC I have different method. So ISC method 1, the easiest method I will use, that is what? Let's see, the ISC is solving by nodal. First I will take nodal. So nodal is what? Nodal method. In the nodal we have just this V, only the voltage, and we have number of node is 2. So KCL equation is 2 minus 1, that is 1. So just wait. So we have 2 nodal equations. Okay, so let's see. Now we have 2 nodes, so we have to apply the one time KCL. Now apply the KCL. So V minus 2 divided by 3 plus V divided by 2 plus V divided by 4/5. Hopefully ये बात समझ में आ रही होगी आपके. So इसको सॉल्व कर लेते हैं. इक्वल्स टू 0. So V minus 2 divided by 3 plus V divided by 2 plus this 5 is going upside, so 5V upon 4 equals to 0. Now what should be the LCM? LCM should be 12. So let's take the 12 LCM now. So 12 is the LCM now. So if we take 12 LCM, that is multiplied by 4, 4V minus 4. If you multiply by 4, then it is 8. If you, here is 2, so it is 6V. Now it is 4, so should be 3. So 3 से multiply करेंगे, it is 15V equals to 0. Now, so let's start. So we have 4 and 6, 10 and 10 and 25V. 25V equals to 8. So V equals to 8 by 25. Now this is not our answer. Okay, now we have to find what? ISC. So ISC we will see. Now ISC is what? If you see the part, this is the expression related to ISC, because this is the current that we have taken. So ISC is what? V divided by 4 upon 5. So V is how much? 8 upon 25, and you have 4 also 4/5. So 4 is as it is and 5 is here. So 5 jar and 4 2 jar. So ISC is 2/5. Now see your answer. If you have the answer, so just please make sure that from the Thevenin's I have also the 2/5. From the Norton I have also calculated the answer 2/5. So this is the advantage of using Thevenin's theorem. Without knowing, you can solve your Norton theorem. Now in this question I have solved this question by nodal. So it is nodal, not nodal. So now second method to solve the ISC is what? I will take mesh method. So I will take mesh. So now next method to calculate the ISC is method 2, just mesh. So now we have two meshes. If you see, I have two meshes, that is I1 and I2, but keep in mind I2 is equals to ISC. प्लीज ध्यान रखिएगा इस बात को, ठीक है। सो अप्लाई करते हैं KVL टू मैश फर्स्ट, KVL टू मैश फर्स्ट। नाउ KVL टू मैश फर्स्ट देखते हैं, 24 माइनस 3I1 माइनस 2I1 माइनस I2 इक्वल्स टू 0। सो अगर मैं बात करूं, इसको सिंप्लीफाई कर लेते हैं, तो 24 माइनस 5I1 प्लस 2I2 इक्वल्स टू 0। Now 5 minus 5I1 plus 2I2 equals to minus 24. So 5I1 minus 2I2 equals to 24. This is equation number 1. Okay. Now, so if you see the second part, the KVL to the mesh second, KVL to mesh second now. So minus 4 by 5 minus 4 by 5 I2 minus 2 I2 minus I1 equals to 0. Now if you simplify this thing, so if you have to take LCM 5, so if you take 5 LCM minus 4 I2 and 5 will multiply here, so it is 10 I2. If you again further multiply by 2, then it is 5, that is, sorry, wait, now it is 10, yeah, it is also 10 but positive, equals to 0. So then 10 I1 minus 14 I2 equals to 0. So 10 I1 equals to 14 I2. So from that I can write I1 equals to 14 upon 10 I2. So if you take I1 equals to 7 by 5 I2, clear hai? But I need I2. So this is the equation number second. Now from this, put the value of I1 in equation first. Okay. So let's put the value, and so it is 5I1 minus 2I2 equals to 24. Now put the value of I1, that is what, 5 into I1 is how much, 7 upon 5 I2 minus 2I2 equals to 24. So 5 से 5 cancel, and 7I2 minus 5I2, that is 5I2 equals to 24, and I2 is what, 24 by 7, sorry, 24 by 5. Is there any mistake? Let's see. Yeah, because I2 should be your 2 by 5. Yeah, 5 is coming where we left the 2. Let's see. Oh, sorry, it is 2. We have the voltage source of 2 volt, but unfortunately we have taken as 2. So please correct it. It is 2, not 24, please mention it. So we have 2, that's why we are having wrong answer 2. Okay, so यहाँ तक clear है? So check कर लीजिए, एक 2 by 5 आ गया. So your I2 is 2 by 5. Now what we have mentioned, I2 is ISC. So this is your ISC. So आपको clear हो रहा होगा कि अभी मैंने नोडल से भी निकाला और मैश से भी निकाला, तो दोनों से आंसर कैसा आ गया, 2 by 5. नाउ एक मैं मेथड और आपको बताना चाहूंगा, जैसे आपके पुराने जो कॉन्सेप्ट हैं वो बिल्कुल रिवाइज रहे. सो आई विल टेल यू द थर्ड मेथड ऑफ कैलकुलेटिंग द ISC in this question. Okay, so let's start the third method. Now, third method of calculating ISC. So if you see the ISC, now method third of ISC, clear? So if you see, the ISC can be calculated from the current divider rule. Okay, so how we apply the current divider rule? Now first, this 4 by 5 and 2 are in parallel. So I'm just 4 by 5 and 2 are in parallel. So 2 into 4 upon 5 upon 2 plus 4 by 5. Okay. So it is 8 by 5. If you see, it is 10, this is 14 by 5. Okay, now, so 14 by 5, 2 to 10, yeah, sure. And 5 से 5 cancel, 8 by 14. So if you further divide, it is 4, it is by 7. So up to here we have 7. Okay, so if you see again, it is 2 and 2, that is 3, and this resistance becomes 4 by 7. Now here the 4 by 7 and 3 are in series. 4 by 7 and 3 are in series. So for the series, 3 plus 4 by 7, if you see, is 21, and for 25 by 7. Okay, so up to here we have 25 by 7. Let's confirm again. 7 3 is 21, and 21 plus 4 5. Yeah, sure. So now this battery will give you the I equals to BYR current. That is 2 upon 25 by 7. So it is 14 by 25. Now यहाँ तक अगर कोई डाउट हो तो देख लीजिए मैंने कर क्या रहा हूँ. मुझे एग्जैक्टली मुझे करंट डिवाइडर लगाना है. दैट्स व्हाई आई एम कैलकुलेटिंग द होल ऑफ द रेजिस्टेंस एट द बैटरी टर्मिनल. ओके, so I have calculated the resistance is 25 by 7 and the battery of 2 volt is providing 14 by 25 ampere current. So I can erase it now. So let's see. Now what is the current divider? Let's see. So हम लोग लगाते हैं इसमें current divider rule. So just erase it. Now the battery is how much giving you current? Sorry, we have erased this. Let's I have to calculate again. Wait. So it is 2 into 4 by 5. Wait, and it is what? 7 by 25. I remember this thing. 25 by 7, or just wait. Let's calculate again. Wait. So 4 by 5 into 2 upon 4 by 5 plus 2. I just calculate in a minute. So it is 8 by 5 and it is 14 by 5. Yeah, sure. It is 4 by 14. Okay. Now 4 by 5 and 3 is this. So it is 3 plus 4 upon, it is 7. 4 by 7, that is 25 by 7. So I is what? V by R. Okay, the V is 2 and it is 25 upon 7. It is 14. 25 by 7. R is 25 by 7. It is 14 upon 25. Okay. So let's see what the current that we have calculated. That is 14 upon 25. Okay. So just erase that thing also. Now अब हमको लगाना क्या है? करंट डिवाइडर लगाना है. Now this 2 volt and 3 ohm are in series, so no current will divide. Up to here the current is same. Now here we have two resistance 4 by 5 and 2. So but I have to calculate the current in ISC. So that is 4 by 5. So current division according ISC equals to the source current is what? 14 upon 25 multiplied by opposite resistance 2 divided by the whole 2 plus 4 upon 5. Agree? So just solve this value. 14 upon 25 into 2 upon it is 10, 14 and it is multiplied by 5. So 14 से 14 cancel out and 5 ja, so it comes out to 2 by 5. So please mention that from all the three methods, I have calculated your ISC as 2 by 5. Now this is your step number first that we have calculated. Now the step number second that we have to find the RN. So RN को हम find करते हैं. Now second step is finding RN. Now RN को find करने के लिए अगर आपको याद हो, so जब हम RN को फाइंड करते थे तो वोल्टेज सोर्स शॉर्ट और करंट सोर्स ओपन. हमारे सर्किट में जो है वोल्टेज सोर्स ही है, करंट सोर्स नहीं है. तो लेट्स सी, इट इज शॉर्ट एंड इट इज 3, इट इज 2 एंड इट इज 4 by 5. Okay, so it is your RTH. Oh sorry, RN, because this time it is RN. Now if you see, both are in parallel. So 2 into 3 upon 5, that is 6 by 5. And this 6 by 5 is in series with 4 by 5. So your RN equals to 4 by 5 प्लस 6/5 दैट इज 2 ओम। होपफुली यहाँ तक बात समझ में आ गई होगी। सो हमने अभी तक IN निकाल लिया, दैट इज 2/5 आया है, और जो RTH आया है वो भी हमारा RN के बराबर आया है, दैट इज 2 ओम। नाउ थर्ड स्टेप हम लोग ड्रॉ करते हैं अब। तो अगर मैं थर्ड स्टेप की बात करूं, so your third step is draw Norton equivalent circuit. Now what is the Norton equivalent circuit? Norton equivalent circuit is the parallel combination of current source and resistance. तो हमने करंट कितनी निकाली थी अगर आपको याद हो, IN जो है हमारे पास वो कितना आया था 2/5, और RN कितना आया था, ये आया था हमारे पास 2 ओम, याद होगा आपको, ठीक है। सो इट इज 2 ओम, एग्री। नाउ अब हमें करना क्या है, हम देखो तीनों स्टेप तक सेम आ गए, हमने यहाँ VTH निकाला था और यहाँ हमने IN और RN निकाला। ना अब हम कर क्या रहे हैं, नोट पॉइंट यहाँ भी देखते हैं। आई जस्ट अप्लाई सोर्स ट्रांसफॉर्मेशन, सोर्स ट्रांसफॉर्मेशन, ठीक है यहाँ तक। ना हमारे पास I है और R है, तो हम लोग VTH निकाल सकते हैं। अगर आपको फॉर्मूला याद हो, VTH इक्वल्स टू IN into RN, so IN is what 2/5 and R is what 2 से 2 cancel, so VTH is 2 volt. If you remember, the VTH should be of, sorry, for 4/5, it is 4/5 because it is 2, it is 5, so it is 4/5. Check your answer. Yeah, we have same answer. So VTH and VTH same, clear? So this is the advantage of this thing. Now similarly, जो RN पैरेलल में लगा हुआ है वही काय में जाएगा, सीरीज में जाएगा। So your RTH equals to RN, that is equals to 4/5 ohm. Now हमने सीखा क्या, अब समझते हैं हमने सीखा क्या यहाँ पर। अगर मुझे थेवेनिन्स थ्योरम परफेक्टली आती है, अगर मुझे थेवेनिन्स थ्योरम है जो अगर परफेक्टली आती है, तो मैं करना क्या है, थेवेनिन्स थ्योरम अगर हमने ड्रॉ कर लिया है, VTH और RTH निकालिए, तो उस पे सोर्स ट्रांसफॉर्मेशन अप्लाई करेंगे, देन यू हैव द नॉर्टन आंसर। नाउ इफ यू हैव परफेक्ट इन योर नॉर्टन थ्योरम, then you just apply the source transformation of the Norton, then you will have the Thevenin's equivalent answer. But मैंने ये दोनों चीजें एक साथ इसलिए बताई हैं, कभी कभी क्या होता है, आपको नॉर्टन करंट जो है शॉर्ट सर्किट से निकालते हैं, और कुछ स्टूडेंट्स को कुछ प्रॉब्लम आती है, शॉर्ट सर्किट करते समय वो करंट की वैल्यू गलत निकाल लेते हैं, क्योंकि डायग्राम में भी जो VTH से जो है वो ज्यादा टफ हो जाता है। इन जनरल तो नहीं होता है, बट इन सब न्यूमेरिकली टफ हो जाता है। तो वहां बेहतर जो होगा, वहां बेहतर होगा कि आप क्या करें, थेवेनिन से सॉल्व कर लें, और RTH और RN तो सेम ही होते हैं, जस्ट IN बराबर VTH अपन RTH कर देंगे तो आपका आंसर आ जाएगा, और आपको क्वेश्चन में मार्क्स मिल जाएंगे, जो कि इंपॉर्टेंट है। इसीलिए मैंने इन दोनों को बताया है। बाकी अब थेवेनिन्स थ्योरम के तो हमने सारे न्यूमेरिकल कर ही लिए हैं। अब हम जो न्यूमेरिकल करेंगे, नॉर्टन थ्योरम पे कुछ और न्यूमेरिकल कर लेंगे, जिससे हमारा कॉन्सेप्ट और क्लियर हो जाएगा। एक न्यूमेरिकल के माध्यम से मैंने आपको दोनों में अंतर बता दिया, लिमिटेशन बता दी, थ्योरी बता दी, क्या हो सकता है वो सब कुछ बता दिया। तो अगले न्यूमेरिकल स्टार्ट करते हैं हम नॉर्टन थ्योरम का।